Hello students, my name is Er.Gurminder Singh and today we will discuss about the index properties of the soil. So in the previous class we have discussed about the physical properties of the soil, which very first we have discussed about the three-phase diagram of the soil. Now in this presentation which you can see on the screen, we will discuss about the index properties, right? So soil classifications are there. What are the soil classifications and what do you mean by the soil classification? So before any type of construction we have to know what type of the soil is available on site or on the field, right? So it is only possible by the laboratory testing and by classify the soil into the different categories on depending upon the its natural behavior and its particle size. So the classified to classify the soil into group according to the soil behavior and the physical shape. What it means? Soil behavior. Soil behaves differently whenever there is a load implement on the soil, right? So there is a strength called shear strength in the soil, as for example in columns we will talk about only about the compressive strength, and slabs we will talk about the compressive as well as tensile strength. Whenever we talk about the soil, we are only talking about the shear strength, right, which is the main strength of the soil. So soil classification is adopting a formal system of soil description and classification in order to describe the various material found in the ground investigation. So before the construction we investigate the ground firstly, that what type of soils stratas are present there beneath the earth, right? So it is also helping to the engineers to found the what type of material beneath the earth before the construction. So move ahead. So what is the soil description? Soil description is the statement where we can found the physical nature and state of the soil, right? So it can be description of a sample. Sample means whatever the sample by the core cutter or many other methods are there to collect the sample from the site, right? Or a soil in situ. There is a word called in situ. What did that mean? It is a very important word in the soil testing field, that in situ, whenever we collect the soil sample at its original place, or we can say that where we have to construct the construct the our projects, and regarding any type of client investigations, we have collected the data from the original place. It is called in situ, right? So whenever we conduct the test on field, it's all called in situ test, or it's arrived by at using using visual examination, simple test, observation of site conditions, as I told you, and geological history, right? So what is soil classification? Soil classification of the soil is a separation of the soil into the different classes. As I told you that we differentiate the soil on the basis of the particle size and their behavior whenever we load applied on that soil on the site, as maybe it's a structural load or maybe it's a machine load, right? So a classification for engineering purpose should be based mainly on mechanical properties. What are their different mechanical properties? First is your permeability, stiffness, and the strength. We will discuss in the next slide what is permeability, stiffness, and the strength. So the aim is the of classification system is to establish the set of conditions which will allow useful comparisons to be made between different soils. So what did that mean? If we have a soil of like nature wise is sand, and otherwise in the other hand we have a clay. So uh, in whenever we comparison the both of the soil, the main difference is that to how they will behave on the implementation of the load. As usual, soil sandy soil provide the maximum drainage to the water whenever it comes in the sand, but as comparison to clay, because as per clay particles are very fine in nature and they haven't provide any type of drainage to the drainage to the water. So as load are applied to that different soils, their behavior are also different because of their nature and because of their nature and drainage purposes, right? So the relevant criteria of the classifying soil are the size, distribution of particles, and the plasticity of the soil. So as I told you that the nature of the soil very firstly distinguish as per the helping of the particle size and the plasticity of the soil, right? So what is the purpose behind the index properties or classify the soil into the different groups? To classify the soil into a group according to the soil behavior and physical shape. So what type of shape of the particles are present there? So what are the different types of classification? Very first is your classification by visual, how the soils are visible by the human eyes, or we can say that in the laboratories without any type of breaking them, we are only observe them naturally. So second is your ASTO, that is your American Association of State Highway and Transportation Organization. So it is not mainly applicable in India, it's only applied this method is only applied in the USA. So third one is your UCS, that is unconfined compressive strength, in which the have to find the shear strength of the soil in the laboratories by using UCS test, right? The very fourth one is your IS classification, Indian standard classification, which is given by the IS code, that you only will have to find by the nature of the soil that what it belongs to the category, what type of categories it is belong to, right? So what are the different soil tests in the laboratories to find the nature of the soil? Very first one is your Utterberg limits. Second is your sieve analysis. Third is your hydrometer analysis. So very first two is important and easily available in the labs, that is your Utterberg limits, which we will find the plasticity, liquid limit of the soil, and also we can find the specific gravity by the different test as by the use of picnometer. So at the Attawag limits we have to find the liquid limit and plastic limit of the soil, whether from the whether we decided that it is the clay or the sandy or silty soil, right? So in the sieve analysis, the major purpose of the sieve analysis is to find the grain size distribution, but type of and what size of particles of the soil are present there. So next is your engineering properties. So engineering properties are mainly arrived from the index properties. Whenever engineers want to find the engineering properties of the soil, they have to very first find out the index properties of the soil. So where we can uh, find the engineering properties. For example, the main engineering properties of the soil are permeabilities, compressibilities, and the shear strength, as I discussed in the previous slides. And what is the permeability? Permeability refers to the water can flow through the soil. So I told you that sand is an provide the path very path or drainage to the water to go through inside from one end to another end. So the permeability of the sand is good as comparison to clay. So it's required for an estimation of seepage discharge through the soil masses. So just to remember that permeability is related to the drainage that is soil is provided to the water, right? So next is your compressibility, that is the main property of your soils, that because soils have to bear all the structural substructure and superstructure loads on it and passes through the beneath to the earth and the in the deeper strata, or we can say that in the strong strata of the soil, right? Compressibility refers to the deformation products produced in soils when they are subjected to compressive loads. It is required for computation of settlements of the structure found on the soil. So it is whenever soil is less compressible, or we can say that having a high capacity to taking loads from the structure, so there is a low change in volume, or soil changes volume as per the loads applied on them, right? So whenever we have a strong soil, the compressibility of the soil is low as comparison to weaker soil. So third one is your shear strength. Shear strength of the soil is the ability to resist shear stresses. So there is a shear stresses which differentiate the whole portion of the soil into two, that one is in upward direction, second is in downward direction. So whenever there is a failure, it's called the shear failure. So I have told you that in columns we can have compressive strengths, in beams we have both compressive and tensile strength due to the steel bars used inside it, but as in the soil we are only talking about the shear strength. So the shear strength determines the stability of the slopes in the hilly areas. The slopes are totally depending upon the shear strength of the soil. Second is your wear capacity of the soil and earth pressure on the retaining structure, right? So whenever we have a low shear strength soils on the hilly areas, maybe a large number of landslides are there due to have a weaker soil. So next, move on to the index properties. The tests required for determination of the engineering properties are required to index properties of the soil. As I told you, engineers have to very first have to find the index property to gain their engineering properties. So simple tests are required to determine the index properties is known as a soil classification test. So there are two type of different tests mainly, which we have to find the index properties. The very first one is your particle size and the relative density. The second is your Auto-work limits. As I told you that in Auto-work limits we have to find the liquid limit and plastic limit of the soil. So very first one is your particle size distribution. What is the particle size distribution? In laboratories we use different type of sieves having different sizes, and by arranging them in a descending order, we can say that upper to lower, we have to sieve the soil from the different type of sieves, and after that we collect the whole portion of the soils from the different sieves and bait them, and as per the by the graphical representation we just differentiate the soil whether it is belongs to the uniformly graded, well graded, etc. So the mechanical analysis, also known as particle size analysis, is the method of separation of soil into the different fraction based on the particle size, right? So for the measuring the distribution of the particle size in the soil sample, it is necessary to conduct different particle size test. It is shown graphically on the particle size distribution graph. So the main point is there, it is graphically represented. Whenever you have find to the numerical values, so after that you will have to find draw on the graph that on x-axis we can show the size distribution, and the finest percentage we can show on the y-axis. So the third point is to the mechanical analysis can be categorized into two types. The very first one is your sieve analysis, second is your sedimentation analysis. So there is a word called sedimentation. What that it mean? That whenever we put any type of wastage or soil in a standing water for specific time period for 24 hours, or maybe more than 24 hours, there are the particles in water are settled down rather than a diluted particle. So that process is called the sedimentation, right? So there are two mainly processes are there. The very first one is your sieve analysis and second is your sedimentation. So there is a particle size where greater than 75 microns, we have to use the sieve analysis, and the particles which have a lesser than 75 microns, the sedimentation process is there, right? So wet sieving is carried out by the soil specimen of the fine grained soil which has the particle size less than 75 micron, and also known as the sedimentation analysis. So there is a point, the exam we are talking about 75 microns. What is that mean? The soil is categorized into the different forms as per the soil, as per the particle size. For the very fine soil, like lesser than the 75 microns, it is categorized as a clay. So from the 75 microns to 4.75 mm, it is categorized into the sand or silty soil. More than 4.75 mm, the soil is called coarse aggregate or maybe gravel, right? So going ahead, the dry sieve analysis is carried out on the particles coarser than 75 micron. Sample are dried and shaking through a set of sieves of descending size. The weight retained in each sieve is measured. The cumulative percentage quantities finer than the sieve analysis or sieve size are then determined. As I told you that number of sieves are put in the descending order, and we have to sieve dry soil. How we dry the soil? We put it into the oven for 24 hours. Then after that we have to perform the sieve analysis or any type of test, right? So the coarse grained soil can be further subdivided into gravel fraction and sand fraction. The size greater than 4.75 mm called the gravel, and size between 75 micron to 4.75 mm is called sand. As I told you, the size between the 75 micron and 4.75 mm is your gravels, and the size lesser than or between the 75 microns to 4.75 mm is called the sand, right? So a set of coarse sieves consisting of the sieve size 80 mm, 40 mm. Just remember that this is 80 mm, 40 mm, 20 mm, 10 mm, and 4.7 mm is 75 mm is required for the gravel fraction. What is gravel are there? The size between 70 the size between or greater than 4.75 mm, right? So that number of sieves are required to sieve the gravels there. Okay, so now going ahead, the second set of sieves consisting of the sieves size, mainly they have a lower in size, starting from the 2 mm, 1 mm, 600 micron, 4.25 212 150 and 75 micron is used to sieve minus 4.75 mm fraction. So whatever fraction we have collected from the last sieve, then we have to sieve through that number of sieves further. So the soil is sieved through the set of coarse sieves manually or using the mechanical shaker. So we have two choices are there. The very first one is your manually, we can sieve them by the using of manpower or by using of by simple hands. So and the other was is your mechanical shaker. There are vibrations or machine vibrations are there in laboratories. You can shaking their well for a certain time of period. Okay, so the weight of the soil retained on the each sieve is obtained. So the resulting data is presented as the distribution curve with the grain size along the x-axis, log scale, and the percentage passing along the y-axis. So what does that mean? I just told you before that whenever we have a graph representing, that is your y-axis, that is your x-axis. Along the y-axis we have to plot the percentage passing, right? So percentage pass, and along the x-axis be just for the grain size, right? So what is your grain size distribution curve? So you can see in the graph there is a curve that represent the clay, silt, sand, gravel or crops, the type of whether the type of soil is there and the percentage finer, right? So the size distribution curve is obtained from the coarse and the fine grained portion can be combined to form the one complete grain size distribution curve, because on the sides we will have to find the one type of soil is there or not, because we cannot say that in within the 5 meters there are different types of soils are there, for it is practically it is not possible. So we have to plot the single curve to find out the percentage finer and their log size. So a special graph is special graph is needed there to plot the curve. It is your logarithmic graph. You cannot show that curve into the simple graphs, right? So from the complete grain size distribution curve, useful information can be obtained in such as what the information which we have to gain from the graph, we can show it into the grading characteristics, which is indicated the uniformity and the range of the grain size distribution. And second is your percentage of gravel, sand, silt and clay size. So there is a word is called uniformity. What did I mean? That whether you have a soil which consists only one type of soil particles, like only gravels, only sand or only silt, whenever there is a mix of their particles, so we can say it's a well graded or it is wow. So how we differentiate it into the uniformities? So we can differentiate it on the basis of that graph plot graph plot between the percentage finer. So a grading curve is useful aid to the soil description. The geometric properties of the grading curve are called grading characteristics. So from the graph it is very clear that we have to divide the percentage finer 10, 30 and 60. So along with that values on the x-axis, we write it into the d10, d30, d60. So what is d10, d30, d60? It's a percentage finer by weight, right? Only the world is there by weight. Why we weight? We have to take the weight of that, because for example whenever you have a 1 kg of soil or 1000 gram of a soil, so you can easily measure that what type of percentage finer are present is there by weight, right? So if the d60 is a size of 60% finer by weight and d30 size is 30% finer by weight, but that mean then d60 means that your 600 grams in 1000 grams, 600 grams or 600 grams are present in your soil as a finer material. In 30 it means 300 grams, 10 it means 100 grams. So the grading characteristics are then determined by the D10s. Then effective size is your D10. Uniformity coefficient, there are two different coefficients which from we can differentiate the soil into the well graded, whether they are well graded, whether they are uniformly or etc., right? So very first one is your uniformity coefficient. So uniformity coefficient means Cu, it is represented by Cu, it is equal to d60 by d10. So what are the units there? It is represented by the percentage. So second is your curvature coefficient, that is represented by Cc, and Cc is equal to d30 whole square divided by d60 into d10, right? So both Cu and Cc will be 1 for a single size soil. If we have a single size soil, like we have only a gravels there, so we can say that Cu and Cc is 1, because the d60 and d10 will be equal to 1, so it is cancel out by each other, so the Cu and Cc will become a 1. So if Cu have a value greater than 5, so we can say that it is a well graded soil, right? So if Cc value coefficient of curvature and the curvature coefficient between 1 to 3 also indicates a well graded soil. What is well graded soil? The different types of silt, sand, clay are present there. So we can also, it's called a C5 soil, which is mainly present in the Punjab areas and the Haryana areas. Okay, so what is Cu? Cu, if less than 3, indicates a uniform soil, that is a soil which has a very narrow particle size range, because in Cu you can say that there is only silt present, or only a sand present, or only a clay sand present. It is uniform, not well graded. So our topic is finished today. So it is a very important topic in the soil mechanics. So for finding the engineering properties, very first we have to find the index properties. So in next class we will discuss about data work limits, how we can find the plastic limits and plastic limit, liquid limit, right? Or how we will represent it on the graphical portion. So thank you very much.